Today's topic is about transformation formulae. See, in the previous lecture, I taught you about compound angle formulae of trigonometric ratios. So, compound angle formulae were of the form sine of a plus b, sine of a minus b, cos of a plus b, cos of a minus b, tan of a plus b, and tan of a minus b. Okay, so we saw what uh, these compound angle formulae will become when you expand this whole thing. Okay, so we had to memorize the formulae for cos, and then we derived the formulae for sine and tan. Okay, now there is one more you can say way of looking at compound angle formulae. That is, you can say sum or difference of compound angle formulae for different trigonometric ratios, and these are called transformation formulae. Now, there is a reason why these formulae are called transformation formulae. As you can see here, sine of a plus b plus sine of a minus b. These are two compound angle formulae for sine. Sine of a plus b and sine of a minus b. This compound angle formulae, the sum of two compound angle formulae, gets transformed into product. So it becomes 2 sine a cos b. It becomes 2 sine a cos b. So sine of a plus b plus sine of a minus b is 2 sine a cos b. Sine of a plus b minus sine of a minus b becomes 2 cos a sine b. 2 cos a sine b. So the only pattern which you have to remember is that if you are taking the sum or difference of sine of two compound angles, if you are taking sum or difference of sine of two compound angles, it becomes 2 times sine a cos b or 2 times cos a sine b. 2 times sine a cos b or 2 times cos a sine b. Okay, but if you are taking sum of sum of cos of two compound angles or difference of cos of two compound angles, then there is a little change. For sum of cos of two compound angles, it becomes 2 cos a cos b, and for difference of two compound angles, it becomes 2 sine a sine b. Okay, when it is difference, you get sine. When it is sum, you get cos. In both the uh, product of cos of two angles. Okay, and there is 2 extra in front of it. So these are some transformation formulae where sum or difference of compound angles of some trigonometric ratios gets converted into product. Okay, so this is one formula, one kind of formula which you have to always remember. Okay, now coming to the derivation. So the first formula is for sine of sum of sine of two compound angles, that is sine of a plus b plus sine of a minus b. Sine of a plus b is sine a cos b plus cos a sine b. Sine of a minus b is sine a cos b minus cos a sine b. So cos a sine b minus cos a sine b gets cancelled, you get 2 sine a cos b. Okay, then difference of sine of two compound angles, sine of a plus b minus sine of a minus b. If you open the bracket, sine of a cos b and minus sine of a cos b gets cut, so you get 2 cos a sine b. Then so derivation is simpler. If you know compound angle formula, you can easily find the sum or difference of two compound angle formulas using transformation formula. Okay, so cos a plus b plus cos a minus b. Cos a plus b is cos a cos b minus sin a sin b, and cos a minus b is cos a cos b plus sin a sin b. Sin a sin b plus and minus gets cancelled, so you get 2 cos a cos b. Okay, then cos of a minus b minus cos of a plus b. Cos of a minus b is cos a cos b plus sin a sin b minus cos of a plus b is cos a cos b minus sin a sin b. So cos a cos a cos b and minus cos a cos b gets cancelled, and you get sin a sin b plus sin a sin b, that is 2 sin a sin b. 2 sin a sin b. Okay, so that's the fourth compound angle formula. In the fourth identity, uh, if you have cos of a plus b minus cos of a minus b, you will not get the same answer. The condition is first you should have cos of a minus b and minus you should have cos of a plus b. Okay. So cos of a minus b minus cos of a plus b is 2 sine a sine b. So I think if you understand the pattern once, you should, of course, memorizing is very important part. You have to memorize. There is no alternative that if you don't memorize you can easily learn the formula. No, you cannot learn the formula by using it alone. You have to memorize. You have to put some effort in memorizing the formula, and then you have to practice more and more, so that by and by you learn all the formulae. Correct. Now the thing is that for memorizing certain patterns are very useful. Okay, so if you see the bigger pattern in these formulae, okay, so if you have 2 sine a cos b, 2 sine a cos b, if you have sine and cos, remember, if you have sine and cos, there are no doublets here, so both the terms will be of sine only. But whenever there is sine, first there will be plus and then there will be minus. First there will be plus and then there will be minus. If you have cos a sine b, again there is no doublet, so there will be sine and only sine involved, not cos. But there will be first plus and then minus, and in between there is minus sign, because cos is first there, therefore you will put minus sign. But if you have cos a cos b, then you have both causes, cos of a plus b and cos of a minus b, and you have plus sign. But if you have sine a sine b, then the sign will be negative in between, but you have cos a minus b first and then cos of a plus b. So certain patterns have to be developed. Only then you will be able to memorize these formulae efficiently. Okay, now the next set of formulae are known as CD formulae. CD formulae. Now it's not necessary that you always write C and D in these formulae. You can make a formula of sine a plus sine b also. Okay, but how you will make that? So first, see, the formula says that sine c plus sine d is 2 sine c plus d by 2 cos c minus d by 2. But how you will make this formula? That is the main question. Okay, so there is not a single formula, but there are 4 formulae. First is sine of c plus sine of d, which has 2 sine c plus d by 2 cos c minus d by 2. Okay, and we have sine c minus sine d, which is 2 cos c plus d by 2 sine c minus d by 2. Then cos c plus cos d is 2 cos c plus d by 2 cos c minus d by 2. See, if there is cos, you get both causes, first plus then minus. If there is minus, then there is a change. Here you have d minus c by 2. That's a slight change from all the other formulae. Cos c minus cos d is 2 sine c plus d by 2 sine d minus c by 2. So if you notice here that if there is minus sign, you get sines over here, sine. If there is plus sign, you get cos. Both are cos. So there are doublets always. Acha, there is plus sign, then there is minus sign. There is plus, there is minus, but there is change of order also. Okay. If there is minus, first will be cos and then there will be sine. First plus and then minus. If it is sine c plus d, first there will be plus, then there will be minus. First sine and then cos. Okay, so if you remember with pattern, it will be easier. Yeah, but the idea is how to memorize these formulae, how to derive these formulae. So let's look at the derivation. So what we'll do is, to find the value of sine c plus sine d, I'm going to substitute. I'm going to use substitution. I'm going to substitute c is equal to a plus b and d is equal to a minus b in our given formula. So c is equal to a plus b, d is equal to a minus b. So what does a become? A is c plus d by 2 and b is c minus d by 2. So sine c plus d is nothing but sine of a plus b plus sine of a minus b. And sine of a plus b plus sine of a minus b is 2 sine a cos b. You want to see the formula? Sine of a plus b plus sine of a minus b is the first one which I am talking about. The first one. Let me just get rid of all this scribbling. Great. So I'm talking about the first one. That's the pattern we are getting here. Sine of a plus b plus sine of a minus b. That is 2 sine a cos b. So if you notice very carefully, you get 2 sine a cos b. So sine of a plus b is sine a cos b plus cos a sin b. Sine of a minus b is sine a cos b minus cos a sin b. ठीक है, cos a sin b minus cos a sin b कट हो जाएगा. So these two terms will get cut. So we get 2 sin a cos b. 2 sin a cos b. तुम डायरेक्ट फॉर्मूला भी अप्लाई कर सकते हो. साइन ऑफ ए प्लस बी प्लस साइन ऑफ ए माइनस बी का डायरेक्ट फॉर्मूला है 2 sin a cos b. ठीक है. अच्छा, अब a की और b की वैल्यू सब्सटीट्यूट कर दो. a है c प्लस डी बाई 2 एंड b है c माइनस. तो साइन c प्लस साइन d का फॉर्मूला हमने डिराइव किया. अच्छा, इन ऑन द सिमिलर नोट you have to derive these remaining formulae. So please pause the video and derive the remaining formulae. In fact, you had to derive the previous formulae also. That is transformation formulae from sum to product. Sum of trigonometric ratios of compound angles to the product of trigonometric ratios. ये सारे चारों डिराइव करना है तुम्हें, और उसके बाद ये चार डिराइव करना है. प्लीज़ डिराइव कर लो. तो वीडियो पॉज करके ये सारे डिराइव करो अभी फॉर्मूले. All right, okay. So I think you have derived. So we have transformation formulae for see, if you notice, हमने compound angle formulae पढ़े, sum and difference of compound angle formulae पढ़े. ठीक है. और उसके बाद we have understood के sum of trigonometric ratios and difference of trigonometric ratios के direct formula क्या है, जिसको हम CD formula बोलते हैं. ये भी हमने कंपाउंड एंगल के फॉर्म से ही इसको डिराइव किया, और ये सिर्फ साइन और कॉस के लिए है. यस, ठीक है. तो सारे फॉर्मूले अपने पास हैं. अब आई थिंक वी आर रेडी टू गो अहेड एंड डू दिस पार्ट. लेट्स स्टार्ट विद दिस एक्सरसाइज ऑफ दिस पार्ट. सो वी हैव टू प्रूव दिस. अब तुम इसको अगर ध्यान से देखते हो तो इट इज ऑफ द फॉर्म ऑफ cos A cos B माइनस cos C cos D. क्योंकि इफ यू सी केयरफुली, ये जो 2 थीटा है, सपोज ये तुम्हारा एंगल A है, तो यहाँ पे 3 थीटा आ गया. ठीक है. एंड यहाँ पे थीटा बाई 2 है, तो यहाँ पे 9 थीटा बाई 2 है. 9 टाइम्स थीटा बाई 2. मतलब ये जो ए बी है, यहाँ पे यू आर गेटिंग समथिंग एल्स. ठीक है. सो दिस हैज टू बी कन्वर्टेड इनटू सम और डिफरेंस ऑफ कंपाउंड एंगल फॉर्मूले. ठीक है. चलो इसको ट्राई करते हैं, कोशिश करते हैं कैसे कन्वर्ट करना है इसको. cos 2 थीटा. So I will write it as cos of 3 theta minus theta. अगर मैं 3 थीटा माइनस थीटा लिखता हूँ cos of a माइनस b, तो मेरा जो cos का फॉर्मूला है दैट इज कॉस ऑफ ए माइनस बी माइनस कॉस ऑफ ए प्लस बी। लेकिन ए प्लस बी में ऐसा होता है कि थ्री थीटा प्लस थीटा आना चाहिए। आई एम नॉट गेटिंग थ्री थीटा प्लस थीटा, सो चलो लेट मी ट्राई कॉस ऑफ ए प्लस बी। कॉस ऑफ ए प्लस बी में टू थीटा की जगह मैं कैसे लिखूंगा, बिकॉज थ्री थीटा साउंड्स नाइस ओवर हियर। ओके चलो देखते हैं। ठीक है, और एक तरीका है इसको सिंप्लीफाई करने का, जो मैंने पहले कोशिश की थी कि मैं इसको स्प्लिट करके लिखूंगा, इसको स्प्लिट करके लिखूंगा, ये तो नहीं समझ में आ रहा है। बट व्हाट आई कैन डू इज आई कैन राइट एल एच एस एज हाफ ऑफ cos of 2 theta into cos of theta by 2 minus cos of 3 theta into cos of 9 theta by 2। ठीक है, एक मिनट, मैंने बाहर हाफ तो मल्टीप्लाई किया, अंदर मुझे 2 मल्टीप्लाई करना पड़ेगा। सो आई एम जस्ट गोइंग टू इरेज दिस, गोइंग टू मल्टीप्लाई 2 ओवर हियर एंड 2 ओवर हियर। इसको ब्रैकेट क्लोज करेंगे और फिर यहाँ पे मैं हाफ मल्टीप्लाई करूँगा। सो आई एम गेटिंग half multiplied by 2 cos A cos B minus 2 cos C cos D। ये अलग फॉर्मूला बन रहा है। सो बेसिकली वी हैव टू अप्लाई द फॉर्मूला ऑफ 2 cos A cos B। ठीक है, 2 cos A cos B क्या है? 2 cos A cos B का फॉर्मूला अगर तुम याद करो, दैट इज cos ऑफ A प्लस बी प्लस cos ऑफ A माइनस बी। ठीक है, cos ऑफ A प्लस बी मीन्स 2 थीटा प्लस थीटा बाई 2 प्लस 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 इसलिए मैं ले रहा हूँ बिकॉज आई हैव 2 cos A cos B। अगर मेरे पास साइन ए साइन बी होता तो मैं माइनस लेता। ठीक है, प्लस कॉस ऑफ ए माइनस बी, प्लस कॉस ऑफ ए माइनस बी मतलब 2 थीटा माइनस थीटा बाई 2। ठीक है, ये हो गया फर्स्ट टर्म, माइनस माइनस इसको मैं माइनस cos of a plus b, that is 3 theta plus 9 theta by 2 plus cos of a minus b, cos of 3 theta minus 9 theta by 2। ठीक है, लेट्स सिंप्लीफाई दिस, हाफ ऑफ, सो ये हो जाएगा cos of 2 theta plus theta by 2 will be 5 theta by 2, cos of 5 theta by 2 plus cos of 3 theta by 2, cos of 3 theta by 2 minus cos of this will be 3 2s are 6, 6 plus 9 15 theta by 2 minus cos of this will be 3 2s are 6 and 6 minus 9 is minus 3 theta by 2, which is nothing but cos of minus theta is minus cos theta. So this will be plus cos 3 theta by 2. Cos of minus theta is minus 3 minus cos of minus theta is cos of minus theta is cos theta. Cos is an even function, right? So this will be 6 minus 9 minus 3 theta by 2. Cos of minus 3 theta by 2 will be cos 3 theta by 2 and there is a minus sign, so this will remain minus. Yes. Correct. So these two terms are going to get cancelled. So I'm getting cos of 5 theta by 2 minus cos of 15 theta by 2. Minus, I'm sorry. Let me write properly. Minus cos of 15 theta by 2. Okay, now we can use CD formulae. If you remember CD formulae, the CD formulae which we are going to use over here is cos C minus cos D. Cos C minus cos D is equal to 2. See, if there is a minus sign, your cos gets converted into sine. 2 times sine of C plus D by 2 minus sine of C minus D by 2. Or sorry, D minus C by 2 minus sine of, sorry, there is no minus sign. There is, it's difference gets converted into, transformed into product. So this is multiplication. 2 sine C plus D by 2 sine D minus C by 2. Okay. So this will become half of 2 sine C plus D by 2, that is 5 theta plus 15 theta by 2, which is 20 theta by 2, which is 10 theta times sine D minus C by 2. Okay, sine D minus C by 2 is 15 theta by 2 minus 5 theta by 2. That is, I think 15 theta by 2 is 7.5 and 5 theta by 2 is 2.5. 7.5 minus 2.5 is 5. So multiplied by sine 5 theta. Sine 5 theta by 2. Sorry. Sine. Hey, how come? 2 sine. Yes. So here it will be 10 theta by 2, because we will have C plus D, right? So we have 5 theta. Yes. Oh, wait. Maybe I'm making some mistake. Yes. So the formula is cos C minus cos D is 2 into sine of C plus D by 2. C plus D by 2. So if you add them, you get 5 theta by 2 plus 15 theta by 2, which is 20 theta by 2, which is 10 theta. 10 theta by 2 is 5 theta. So here you will get 5 theta times D minus C by 2. 5 theta by 2 minus, sorry, 15 theta by 2 minus 5 theta by 2, which is 10 theta by 2, which is 5 theta, and divided by 2 will give you 5 theta by 2 sine of 5 theta by 2. I'm sorry, sine of 5 theta by 2. Okay, so you just open the bracket and cut this 2 with this 2. So you get sine of 5 theta times sine of 5 theta by 2. That should be your final answer. Yeah, many glitches from my side. It was not very smooth, but yeah, still you understand. Okay, so first we started with the use of 2 sine a, 2 cos a cos b, the formula of 2 cos a cos b, minus 2 cos a cos b, again the formula of 2 cos a cos b. We expanded it and then we simplified, and then we used the formula of sine c minus cos c minus cos d, which is 2 sine c plus d by 2 into sine d minus c by 2. Okay, so we proved what needed to be proved. Let's go ahead. Okay, prove that tan of 60 plus a into tan of 60 minus a is equal to 2 cos 2a plus 1 upon 2 cos 2a minus 1. So I think first tan should be converted into in the form of sine and cos. So LHS is equal to sine of 60 plus a upon cos of 60 60 plus a times sine of 60 minus a upon cos of 60 minus a. Okay. What we can do is we can write it like this. 2 sine 60 plus a times sine 60 minus a, the whole upon 2 cos 60 plus a times cos 60 minus a. So I'm multiplying and dividing by 2. So I'm not changing any term. So this is of the form 2 sine a sine b upon 2 cos a cos b. So 2 sine a sine b, 2 sine a sine b. See, we have doublet over here and we have in the form of sine. So 2 sine a sine b will be equal to cos of see, we have 2 sine a sine b. Okay, so first is we will have cos of a plus b, that is 60 plus a plus 60 minus a. Okay, then we will have minus sign, minus cos a minus b, cos a minus b. A is 60 plus a minus 60 plus a. Okay, so that becomes cos of 120, cos of 120 minus cos of 2a, cos 120 minus cos 2a. Let me check the formula. So 2 sine a sine b, 2 sine a sine b is cos of a minus b minus cos of a plus b. So yeah, I was wrong over here. We have minus sign here, and then we have plus sign over here. Okay, 2 cos a cos b, 2 cos a cos b. We have cos of a plus b plus cos of a minus b. A plus b. Wait. A plus b is 60 plus a plus 60 minus a plus cos of a minus b. 60 plus a minus 60 minus a. Okay, so this will be, if you open the bracket, it will become cos 2a minus, this will become, sorry, this is cos of 60 minus a. Okay, so this will become cos 120. This will become cos 120 plus this will become cos 2a. So we have cos of 2a minus cos of 120 upon cos of 120 minus plus cos of 2a. Okay, so here what I'm going to do is I'm going to put the value of cos 120. Now, do you know what is cos 120? If you don't know, there is a technique. Cos of 120 can be written as cos of 180 minus 60. Okay. Now, 180 minus 60 is the second quadrant. In second quadrant, cos is negative. So, whatever answer you are going to get is negative. Okay. So, you are going to get the answer of minus cos 60. Okay. That is minus 1 by 2. Okay. Minus 1 by 2. So, cos 2a minus 1 by 2, which is plus 1 by 2, upon minus 1 by 2 plus cos 2a, or cos 2a minus 1 by 2. So, you can write it as cos 2a plus 1 by 2 upon cos 2a minus 1 by 2, right? We can take LCM and simplify this further so that we can get this answer. Okay, so this will become 2 cos 2a plus 1 the whole upon 2, the whole divided by 2 cos 2a minus 1 the whole upon 2. 2 gets cancelled. So, we get 2 cos 2a minus 1 upon 2 cos 2a, 2 cos 2a plus 1 upon 2 cos 2a minus 1. Okay. So, this is what you get when you solve this equation. Easy. Transformation formulae, not very easy, but they are a little tricky, but yeah, with practice you can definitely get it, and you must remember most of the formulae. They are very important. Without formulae you cannot do anything here. Okay, here we have sine of 150 plus x plus sine of 150 minus x is equal to cos x. We have to prove this. So, LHS, sine of 150 plus x plus sine of 150 minus x. Now, this is of the form sine of a plus b plus sine of a minus b, and this is nothing but, so let me write the identity over here, using sine of a plus b plus sine of a minus b is equal to 2 sine a cos b. 2 sine a cos b we can write directly as 2 sine 150 multiplied by cos x, 2 times sine 150 multiplied by cos x. Okay, so how we can find the value of sine 150? So 2 times sine of 90 plus 60 is 180, right? Wait, why shouldn't I write it as 180 minus 30? That is easy, na? Okay. So 2 sine 180 minus 30. See, sine 180 minus 30 is in second quadrant. In second quadrant, sine is positive. So I can write it as sine 30 into cos x. And sine 30 is nothing but 1 by 2 into cos x. 2 gets cancelled. I get cos x, which is RHS. Easy. Let's go to the next question. I hope you are noting everything down. If angles A, B and C are in AP, prove that cot B is equal to sin A minus sin C upon cos C minus cos A. Okay, see, A, B and C are in AP. Okay, so B minus A must be equal to C minus B. That means B plus B is equal to C plus A. So 2B is equal to A plus C, or A plus C is equal to A plus C by 2 is equal to B. So we got the relation between A, B and C. Okay, so let's check the RHS, which is sin A minus sin C, the whole upon cos C minus cos A. Okay. Okay, so let's use the formula of sin C minus sin D. Okay, you remember the formula of sin C minus sin D? Let me tell you here. Sin C minus sin D is equal to 2 cos C plus D by 2 times sin C minus D by 2. 2 cos C plus D by 2 times sin C minus D by 2. Okay, so sin A minus sin C is 2 times cos of C plus D by 2. That is A plus C by 2 times sin A minus C by 2. A minus C by 2. Okay, the whole upon cos C minus cos A. Cos C minus cos D. What is the formula? Cos C minus cos D is 2 sin C plus D by 2 times sin D minus C by 2. D minus C by 2. Okay, so this will become 2 into sin A plus C by 2 times sin D minus C. So here D is A and C is C. Okay, so A minus C by 2. So automatically these two terms will cut. So and 2 will cut. So we get cos upon sine. Cos theta upon sine theta is cot theta. Cot of A plus C by 2. We already know A plus C by 2 is B. So that is cot B, which is your LHS. Okay, moving on to the next question. Next question. Prove that cos alpha plus cos beta the whole square plus sin alpha plus sin beta the whole square is equal to 4 cos square alpha minus beta by 2. Okay, so here it's going to be a little long question, but if you pay attention it will be easy. Okay, so what we are going to do is we are going to use the formula of cos C plus cos D and sin C plus sin D in LHS, because that's the only formula which seems applicable. Otherwise it will keep on becoming complicated. Or else what you can do is you can expand everything. You can expand everything and then simplify, so that what will happen is you get the term of cos square alpha plus sin square alpha as 1 and cos square beta plus sin square beta as 1. But what are you going to do about 2 cos alpha cos beta and 2 sin alpha sin beta, right? Because what you want is not in the terms of 2 cos alpha cos beta. Uh, See, we can try that, but I'm not sure that where it's going to lead us. 2 cos alpha cos beta, 2 sine alpha sine beta. 2 cos alpha cos beta is cos of alpha plus beta plus cos of alpha minus beta. Here we don't want anything like that. Here what we want is in the terms of alpha minus beta by 2. So I think applying the formula of CD formulae is a sensible thing over here. So let me apply CD formulae in LHS. LHS is cos alpha plus cos beta the whole square plus sine alpha plus sine beta the whole square. Okay, so cos C plus cos D is 2 cos C plus D by 2, 2 cos alpha plus beta by 2 times cos C minus D by 2, cos alpha minus beta by 2, and this thing we are going to do whole square plus sine alpha plus sine beta. Sine alpha plus sine beta is 2 sine alpha plus beta by 2, 2 sine alpha plus beta by 2 times cos alpha minus beta by 2, that is sine C plus sine D, cos alpha minus beta by 2 the whole square. Okay, so in the next step I'm going to square and open the bracket, so it's going to become 4 cos square alpha plus beta by 2, 4 cos square alpha plus beta by 2 times cos square alpha minus beta by, hey, it's going to become 4. No, it's not going to become 4. That's the angle. So cos square alpha plus beta by 2 times cos square alpha minus beta by 2 plus 4 sine square alpha plus beta by 2 times cos square alpha minus beta by 2. Okay, and from here what you can do is you can get 4 cos square alpha minus beta by 2 outside, and inside you'll be left with cos square alpha plus beta by 2 plus sine square alpha plus beta by 2, which is going to become 1. So you're left with 4 cos square alpha minus beta by 2, which is your RHS. Let's go to the next question. Okay, if sine theta plus sine alpha, sine theta plus sine alpha is equal to root 3 times cos alpha minus cos theta, prove that sine 3 theta plus sine 3 alpha is equal to 0. Okay, let's start with the statement which is given to us, that is sine theta plus sine phi, sine theta plus sine phi is equal to root 3 times cos phi minus cos theta. Sine theta plus sine phi is equal to root 3 times cos phi minus cos theta. Now in the LHS we can apply the formula of cos sine C plus sine D, and we know that sine C plus sine D is 2 sine C plus D by 2, 2 sine c plus d is theta plus phi, theta plus phi by 2 times cos c minus d by 2, cos theta minus phi by 2, okay, is equal to root 3 times cos phi minus cos theta. Cos phi minus cos theta, cos c minus cos d. 2 cos c plus d by 2, c plus d, 2 cos c plus d by 2, that is cos c minus d, right? Sorry. Small mistake. We are applying the formula of cos c minus cos d. Cos c minus cos d is 2 sine c plus d by 2. 2 sine phi plus theta by 2 times sine d minus c by 2. D minus c. Theta minus phi by 2. Okay. Great. So, if you open the bracket, some things are going to cut. So, 2 sine theta plus phi by 2 cos theta minus phi by 2 is equal to 2 root 3 times sine phi plus theta by 2 times sine theta minus phi by 2. So, we have sine theta plus phi or phi plus theta by 2 on both the side. We are going to cut it, and 2 is there. We are going to cut that as well, and we'll be left with uh, cos of theta minus phi by 2 and sine of theta minus phi by 2. So, we'll be getting cos of theta minus phi by 2 upon sine of theta minus phi by 2 is equal to root 3. So, that is cot of theta minus phi by 2, which is equal to root 3. So, theta minus phi by 2 is equal to, so root 3 is cot 30 degree. Okay, so I'm going to write 30, that is pi by 6. Okay, 2 will get multiplied over here. So 2 into pi by 6 is pi by 3. Let me theta minus phi is pi by 3, correct? Okay, great. So we got the value of theta minus phi. Now let's see how to proceed ahead. Now we have to find the value of sine 3 theta plus sine 3 phi. Okay. So can we write it as theta is equal to pi by 3 plus phi, and we have to find the value of sine 3 theta plus sine 3 phi. Okay. So in the place of theta, I'm going to write pi by 3 plus phi. So this will become sine of 3 times pi by 3 plus phi plus sine 3 phi. So this will become sine of 3 will get multiplied and will get pi plus 3 phi plus sine 3 phi. Okay. So sine of 180 is the interval of sine, right? So sine is a periodic function for from 0 to pi. So it will again get again it will repeat itself and will get sine of 3 pi plus sine of 3 pi. 3 phi actually, not pi. So 2 sine 3 phi. 2 sine 3 phi. Okay. Uh, Wait, I think sine of pi plus 3 phi will be, hey, pi is, no. So this is wrong. Actually, pi plus 3 phi will land you in the third quadrant, and in third quadrant sine is negative. So this will be sine of minus 3 phi. That is minus sine of 3 phi. Minus sine of 3 phi plus sine of 3 phi will be equal to 0. Yes, so now it is proved that sine of 3 theta plus sine of 3 phi is 0. Okay, great. Let's go to the next question. Prove that cos A plus cos B upon sin A minus sin B the whole raised to n plus sin A plus sin B upon cos A minus cos B the whole raised to n is equal to 2 cot raised to n of A minus B by 2 if n is even and 0 if n is odd. Slightly tricky question but can be solved easily because we don't have to focus on RHS, what has to be proved. हम लोग सिर्फ LHS पे फोकस करेंगे जो साइन सी प्लस कॉस डी के फॉर्मेट में, ठीक है, वही सारे फॉर्मूले वहाँ पे लगेंगे. सो विल लेट्स फोकस ऑन LHS. So LHS will become cos A plus cos B upon sin A minus sin B plus the whole raised to n plus sin A plus sin B the whole upon cos A minus cos B the whole raised to n. Okay, so let's apply the formulae. Cos A plus cos B. Cos C plus cos D is formula basically. So 2 cos C plus D by 2. 2 cos C plus D. In the place of C plus D, I'm going to write A plus B. 2 cos A plus B by 2 times cos C minus B by 2. C minus D is A minus B. The whole upon sin A minus sin B. 2 cos C plus D by 2 times cos C minus D by 2. Okay, so this is only this first bracket, the whole raised to n. I did not write it. Now the second part of the bracket, second part of the term, second bracket, sin A plus sin B is 2 sin A plus B by 2 times cos A minus B by 2 the whole upon cos A minus cos B is 2 sin A plus B by 2 times sin B minus A by 2 the whole raised to n. Okay, so here 2 is going to get cut. Cos of a plus b by 2 and cos of a plus b by 2, it's going to cut. And wait, there is some mistake. Sine a minus sine b. Okay, so this is not cos, this is sine. Yeah, everything else is okay. Okay, this is going to cut straight away. 2 is going to cut. Sine of a plus b by 2, sine of a plus b by 2 is going to cut. So we'll be left with cos of a minus b by 2 upon sine of a minus b by 2, which is cot of a minus b by 2, cot raised to n of a minus b by 2 plus, okay, so remember that here we have sine of b minus a by 2, which can be written as minus of, sorry, sine of minus of a minus b by 2, and sine minus theta is minus sine theta. So that minus can be brought over here, and I'm going to convert it into minus, and here also I'm going to write cot of a minus b by 2 the whole raised to, sorry, cot raised to n. Now this clearly looks like it is 0, but when n is even, suppose we have cot square, when n is even, I cannot prove it, I'm just getting it 0. Okay, let me check what they have done over here. Oh, okay. So that minus thing what I did was little bit in hurry. Actually, it should have been that minus sign. If I take out, it also has raised to n inside it. Okay, so I cannot write it like this. Just that part is wrong. So I have to write plus minus 1 raised to n, because that minus 1 is taken out, and here it will become uh, cot raised to n of a minus b by 2. Okay, so this is basically what you get, and this uh, minus 1 raised to n. Okay, so that's going to become minus 1 if n is odd, and that's going to become plus 1 if n is even. So if in case n is even, we get 2 cot raised to n a minus b by 2, but if n is odd, we get 0 as the answer. So on simplification, we can prove it easily. Okay, next question. If sin x plus sin y is equal to a and cos x plus cos y is equal to b, find the value of tan of x plus y and tan of x minus y, tan of x plus y by 2 and tan of x minus y by 2. Okay. See, they have given that sine of x plus sine of y is equal to a. Okay, let's first put the formula of sine c plus sine d. Okay, so sine c plus sine d is 2 sine c plus d by 2 cos c minus d by 2. So we'll write it as 2 sine x plus y by 2 cos x minus y by 2 is equal to a. Okay, so what we'll do is, we cannot do anything to it right now. Okay, so let's leave it as it is. Okay, make it equation number 1. and we have another equation as cos of x plus cos of y is equal to b, which becomes cos c plus cos d, which is 2 cos a plus b by 2 c plus d by 2 times cos c minus d by 2. 2 cos x plus y by 2 times cos x minus y by 2 is equal to b, equation number 2. Now you can get tan if you have sine by cos. So dividing equations 1 and 2, we have 2 sine x plus y by 2 times cos x minus y by 2, the whole upon 2 cos x plus y by 2 times cos x minus y by 2 is equal to a by b. Okay, so this 2 gets cancelled from both the sides, from numerator and denominator, I'm sorry. And cos of x minus y by 2 gets cancelled. So we get tan of x plus y by 2 as a by b. Okay. What about tan of x minus y by 2? How you'll find that? Now, there is an interesting step which we are going to do to find tan of x minus y by 2. Please pay attention. So what we are going to do is we are going to square both the sides and add them, and you will see how the terms get you can say simplified, and we get tan of x minus y by 2. So we have to squaring 1 and 2 and adding. Okay, so we get 4 sine square x plus y by 2 times cos square x minus y by 2 plus 4 cos square x plus y by 2, 4 cos square x plus y by 2 times cos square x minus y by 2 is equal to a square plus b square. So can you see what is common out of both of them? 4 cos square x minus y by 2 is common. So what is left inside? So inside you are left with sine square x plus y by 2 plus cos square x plus y by 2 and is equal to, you get over here 1. Oh, sorry, not 1. A square plus b square. I'm sorry for that. So finally this becomes 1 and you get 4 cos square x minus y by 2 is equal to a square plus b square. Okay, but I want the value of tan of x minus y. So I can find the root of this thing first. If I do square rooting both the sides, you get 2 cos x minus y by 2 is equal to under root of plus minus under root of a square plus b square. Okay, now I just want sine of x minus y by 2's value. Do I have sine of x minus y? Sine of x minus y. Do I have sine of x minus y? No, I don't. Let me check. Okay, so I was in a little hurry for finding the square root. Uh, Actually, there is an easy method to find tan. Okay, so I had 4 cos square x minus y by 2 is equal to a square plus b square. All right. So we have cos square x minus y by 2 is equal to a square plus b square by 4. So sec square x minus y by 2 is equal to 4 upon a square plus b square, because sec is the reciprocal of cos, and now we can get the value of tan. Sec theta is 1 plus sec square theta is 1 plus tan square theta. So 1 plus tan square x minus y by 2 is equal to 4 upon a square plus b square. Shift that 1 over that side. So tan square x minus y by 2 is equal to 4 upon a square plus b square minus 1. Okay. So tan square x minus y by 2 is equal to 4 minus a square minus b square upon a square plus b square, and we have tan of x minus y by 2 as plus minus under root of 4 minus a square minus b square upon a square plus b square. So that was a little long way, but that is the only way with which we can get tan of x minus y by 2. Tan of x plus y by 2 was easy, but tan of x minus y by 2 was a little longer. We got it. Next question. Prove that sine 10 into sine 50 into sine 60 into sine 70 is equal to 3 by root 16. Okay. You need to simplify this in a very nice way. Okay, let's do this. Okay, let's start this one. LHS is sine 10 degrees times sine 50 degrees times sine 60 degrees times sine 70 degrees. Okay. Now out of all these, we know the value of sine 60. Sine 60 is root 3 by 2. So what you can do is, you can take root 3 by 2 ahead. That is the value of sine 60. Then you can write sine 10, sine 50 and sine 70. Now out of these three values which are left, sine 10, sine 50, sine 70, club any two of the values together whose sum or difference will be a standard angle. जैसे 50 और 10 का जो सम है वो 60 है, जो स्टैंडर्ड एंगल है, उसकी साइन 60 की वैल्यू हमें पता है, और 50 और 10 का डिफरेंस स्टैंडर्ड एंगल नहीं है. वैसे ही 50 और 70 का सम 120 है, विच कैन बी कन्वर्टेड इनटू अ स्टैंडर्ड एंगल, बट 50 और 70 का डिफरेंस 20 स्टैंडर्ड एंगल नहीं है. तो किसी भी दो वैल्यूज को क्लब कर सकते हो. सो आई हैव डिसाइडेड टू क्लब दीज टू. इनको साथ में क्लब करेंगे तो ये हो जाएगा रूट 3 by 2 टाइम्स 2 sine 10 times sine 50 the whole upon 2. मैंने क्या किया, 2 से मल्टीप्लाई और डिवाइड कर दिया, टाइम्स sine 70. अब ये जो 2 है उसको ये 2 से मल्टीप्लाई कर सकते हैं, तो √3/4 टाइम्स 2 साइन ए साइन बी। ठीक है, 2 साइन ए साइन बी क्या होता है? 2 साइन ए साइन बी, पहले जब भी देखो, पहले इफ़ यू आर गेटिंग साइन, इसको कैसे लर्न करना है वो मैं तुम्हें बता रहा हूँ। 2 साइन ए साइन बी, इफ़ यू आर गेटिंग साइन, इसका मतलब है कि यू आर गोइंग टू गेट कॉस इन द सम एंड डिफरेंस ऑफ दैट कंपाउंड एंगल वाला फॉर्मूला। ओके, एंड बिकॉज यहाँ पे साइन है दोनों जगह पे, तो हम लोग कॉस डालेंगे, पहले माइनस फिर प्लस, पहले माइनस फिर प्लस। सो इफ यू आर नॉट रिमेंबरिंग, आई टेल यू, 2 साइन ए साइन बी इज इक्वल टू cos of a minus b, cos of a minus b minus cos of a plus b, cos of a minus b minus cos of a plus b. Okay, so this will be 2 times cos of a minus b. Okay, now yes, cos of a minus b will be cos of 10 minus 50. Cos of 10 minus 50 is cos of minus 40, and cos of minus theta is cos theta. Okay, so I can write it, why did I write 2? There is no need of 2. Directly I can write it cos of 40, cos of 40 minus, because there is a minus sign, cos of 50 plus 10, that is cos 60, cos 60. ठीक है, so 2 sin a, 2 sin a sin b is cos of a minus b minus cos of a plus b times sin 70. Sin 70 will be as it is. Okay, so here we are going to get √3/4 times cos 40 minus cos 60 is 1/2 times sin 70. Now this sin 70 and this √3/4 will get multiplied with each of the term inside the bracket. So we have √3/4 times cos 40 sin 70 minus 1/2 times √3/4 times sin 70. ठीक है, अब इसको आगे सिंप्लीफाई करते हैं हम लोग. Okay, so what we have got over here is √3/4 cos 40 sin 70, cos 40 sin 70. अब इसको we can write it as 2 cos 40 sin 70, बट 2 से मल्टीप्लाई किया तो नीचे डिवाइड भी करना पड़ेगा. ठीक है, और यहाँ पे what we have got is √3/8 sin 70. ठीक है, okay, so here also we get √3/8 times 2 cos a sin b, 2 cos a sin b. लर्न करो फॉर्मूले. 2 cos a sin b किसका फॉर्मूला है? देखो, cos और sin आया, पहले cos आया फिर sin आया, तो दिस विल बी, डबलेट नहीं है, मतलब ये sin का फॉर्मूला है. sin ऑफ a प्लस बी माइनस साइन ऑफ a माइनस बी, साइन ऑफ a प्लस बी. 40 plus 70 is 110. 2 cos a sin b, right? Minus sine of a minus b, minus sine of a minus b. Sine of a minus b is sine of 40 minus 70, which is sine of minus 30. ठीक है, minus √3/8 sin 70. इसको सिंप्लीफाई करते हैं. √3/8 टाइम्स ये हो जाएगा साइन ऑफ 110 जो है ना, आई कैन राइट इट एज 180 minus 70. साइन ऑफ 180 minus 70, साइन ऑफ 110. अच्छा, साइन ऑफ माइनस थीटा इज माइनस साइन थीटा, right? Sine of minus theta is minus sine theta. So minus minus will become plus, sine 30 माइनस √3/8 साइन 70। एक मिनट, ये जो √3/8 था ये दोनों के साथ मल्टीप्लिकेशन में था, तो बीच में प्लस साइन आ गई, आई हैव टू पुट अ ब्रैकेट ओवर हियर। ठीक है, सो √3/8 टाइम्स साइन ऑफ 180 minus 70, it will be sine 70 only. You know why sine 70? Because 180 minus 70 lies in the second bracket. In the second bracket, sine is positive. So this will be sine 70 plus sine 30 is 1/2 minus √3/8 times sine 70. Okay, so √3/8 sine 70 plus 1/2 into √3/8 is √3/16 minus √3/8 sine 70. So ये तो कट हो जाएगा and I'll be left with √3/16. Okay, let's see what we had to prove. I think यही हमें प्रूव करना था. Yes. So as I told you earlier कि इसमें काफ़ी steps है जिसमें इसको simplification के लिए हमें यूज़ करना पड़ेगा. So I hope you understood this. Let's go to the next question. Okay. Prove that cos 4x plus cos 3x plus cos 2x upon sin 4x plus sin 3x plus sin 2x is equal to cot 3x. ठीक है, चलो लेट्स सी कैसे करना है इसको. LHS से शुरू करेंगे ऑफ कोर्स. cos 4x plus cos 3x plus cos 2x upon sin 4x ठीक है. सो LHS हमने लिख दिया. अब क्या करेंगे? अब ये जो cos 4x और cos 2x है ना, इसको साथ में लाएंगे बिकॉज हमको चाहिए cot 3x. तो 3x वाली टर्म्स तो हम लोग इसको टच नहीं करेंगे, बाकी वाली टर्म को हम लोग कट करने की कोशिश करेंगे. ठीक है, कैसे होता है देखते हैं. सो व्हाट विल डू इज विल राइट cos 4x प्लस cos 2x इन ब्रैकेट, और उसके साथ फिर हम लोग लिखेंगे cos 3x द होल अपॉन sin 4x प्लस sin 2x लिखेंगे प्लस sin 3x को अलग से लिखेंगे. ठीक है, अब ये जो cos 4x और cos 2x है इसको कैसे हम लोग लिखें? ये देखो, cos of 3x plus x plus cos of 3x minus x plus cos 3x the whole upon sine of 3x plus x plus sine of 3x minus x plus sine 3x. Cos a plus b plus cos a minus b, sum of compound angle formulae, that is 2 cos a cos b, 2 cos a cos b. This is a, this is b. 2 cos a cos b plus cos 3x. Okay, 2 cos a cos b. Okay, नीचे क्या आएगा? साइन ए प्लस बी प्लस साइन ए माइनस बी. साइन आता है तो डबलेट नहीं आता है, तो वी गेट 2 साइन ए कॉस बी, 2 साइन ए cos b, 2 sine a cos b plus sine 3x. Let's take cos 3x कॉमन. cos 3x अगर कॉमन निकालेंगे तो अंदर क्या बचेगा? 2 cos x प्लस 1 और नीचे क्या कॉमन आएगा? sin 3x. अंदर बचेगा 2 cos x प्लस 1, कट जाएगा और ये हो जाएगा cot 3x. cos 3x by sin 3x will be cot 3x, which is equal to your RHS. Easy. Just grouping the terms together and you get the answer. Next question. Prove that cos alpha plus cos beta plus cos gamma plus cos of alpha plus beta plus gamma is equal to 4 cos alpha plus beta by 2, cos beta plus gamma by 2, cos gamma plus alpha by 2. Okay. At the first instant, it looks very complicated, this question, but we have to apply right steps, and with those right steps it's going to get proved easily. But let's see how we are going to crack this. So we'll start with LHS, that is cos of alpha plus cos of beta plus cos of gamma plus cos of alpha plus beta plus gamma. Okay, we have to convert that into this. So grouping is the right way. First I'm going to group cos alpha plus cos beta together, cos alpha plus cos beta together, and in the next group I'll be having cos of alpha plus beta plus gamma plus cos of gamma together. Okay, so as you know, cos C plus cos D is 2 cos C plus D by 2 cos C minus D by 2. Okay, so we'll write 2 cos C plus D by 2 into cos C minus D by 2, that is alpha minus beta by 2. Okay, and here also I'm going to apply the same formula, cos C plus cos D, 2 times cos of C plus D by 2, that is alpha plus beta plus gamma, that is alpha plus beta plus 2 gamma by 2 times cos of alpha plus beta plus gamma minus gamma, that is alpha plus beta by 2. Okay, next I'm going to take out 2 cos alpha plus beta by 2 common. So I'll be left with cos of alpha minus beta by 2, cos of alpha minus beta by 2 plus cos of alpha plus beta plus 2 gamma by 2, alpha plus beta plus 2 gamma by 2. Okay. If you see inside the bracket, looks complicated, but again we have the format of cos C plus cos D. We can solve it. Cos C plus cos D formula we already know. So 2 cos alpha plus beta by 2. If you are wondering, we have already got 2 out of this 4, and cos of alpha plus beta by 2 we have already got. We just have to get the remaining terms. We will get. but we have to simplify the brackets. Cos C plus cos D is 2 cos C plus D by 2, 2 cos C plus D, that is alpha minus beta by 2 plus alpha plus beta minus 2 gamma by 2. Okay, so if you add them, you get beta and minus beta gets cut, and you get alpha plus alpha 2 alpha, and gamma is not there. So 2 gamma, 2 alpha plus 2 gamma by 2, that is alpha plus gamma by 2. No, alpha plus gamma, 2 cos alpha plus gamma, just alpha plus gamma, because we get 2 alpha plus 2 gamma by 2 and 2 gets cancelled, so we get cos of alpha plus gamma, 2 cos of alpha plus gamma. Okay, and so we get multiplied by cos of alpha minus beta by 2. So if you subtract them, we get alpha minus beta minus alpha minus beta minus 2 gamma. Okay, so alpha gets cut and we get minus beta minus 2 beta, cos of minus 2 beta minus 2 gamma by 2. So that is, if you take out minus common, it will be cos of minus 2 alpha plus beta by 2. Minus minus gets cancelled. Cos of minus theta is cos theta. So cos of alpha gets cut. So we get beta plus gamma by 2 gets cut. Okay, so we get cos of okay, just a moment, that there is just one small problem here, that when I did it all orally, that's why. So small mistake, let me just simplify this. So see, cos C plus cos D is equal to 2 cos of C plus D by 2 times cos of C minus D by 2. Okay, so we get 2 times cos of C plus D by 2, that is alpha minus beta by 2 plus alpha plus beta plus 2 gamma by 2, the whole upon 2. Yeah, I did not write this 2. I did not actually use this 2. So that was a huge problem, right? So this cos also has to be written over here. This is a huge mess because it's a big bracket, right? Hmm. 2 cos alpha minus beta by 2 plus alpha plus beta plus 2 gamma by 2 times cos, the same thing but with a minus sign, C minus D by 2, alpha minus beta by 2 minus alpha plus beta plus 2 gamma by 2, the whole upon 2. Now if you simplify this and see, what are you going to get? So it's easy for me to explain now. See here, minus beta and plus beta will get cancelled. So 2 alpha plus 2 gamma by 2, that is alpha plus gamma, but this whole upon 2 will remain as it is. And here I'm going to get minus 2 beta minus 2 gamma by 2, which is minus 2 of alpha plus gamma, sorry, beta plus gamma by 2, and this 2 will remain as it is. Okay, so this cos of minus theta will become cos theta. So this will look like this. Just let me write over here. This expression will look like 2 cos of alpha plus beta by 2 times 2 times cos of this will become alpha plus gamma by 2 times cos of beta plus gamma by 2. Beta plus gamma by 2. Yes, and if you open the bracket, it will become 4 times cos of alpha plus beta by 2 times cos of gamma plus alpha by 2, or alpha plus gamma by 2 times cos of beta plus gamma by 2. That's what you wanted. Yes. Okay, so yeah, a little complicated in between, but can be shown. 2 more questions. This is the second last question. Very long. I know it's very long questions, and I have to show you, but we can't help it. Videos are becoming long, but we can't help it. Till I show you, you will never get it. If sine theta is equal to n sine theta plus 2 alpha, show that tan theta plus alpha is equal to 1 plus n by 1 minus n tan alpha. Okay, so I think this is also componendo dividendo. Let's see. So they have given sine theta is equal to n times sine of theta plus 2 alpha. So sine theta upon sine of theta plus 2 alpha is equal to n by 1. So by componendo dividendo, you get sine theta plus sine of theta plus 2 alpha upon sine theta minus sine of theta plus 2 alpha upon n plus 1 upon n minus 1. Right? See, you want 1 plus n upon 1 minus n. You can do that. So this will become sine of theta plus 2 alpha plus sine theta the whole upon sine of theta plus 2 alpha minus sine theta is equal to 1 plus n upon 1 minus n. Yeah. So now what you have to do is, I'm not going to solve this further. You have to do it because I'm showing you the way. You have to apply the formula of cos C plus cos D and sine C plus sine D and sine C minus sine D in the numerator and denominator and simplify. And I'm sure you are going to get something in terms of tan. Okay, so please pause the video and solve this further. This was just a hint for you. Please do it. Okay, let's check the answer. Yes, so they have applied the formula of sine C plus sine D in the numerator and denominator, simplified it and got the value, got the answer as in terms of tan theta plus alpha and tan alpha. Okay, the last question. You please check it, okay? If you have made any mistakes, please correct it. If alpha plus beta is 90, then find the maximum and minimum value of sine alpha sine beta. See, alpha plus beta is 90. We have to find the value of sine alpha sine beta. So let x be equal to sine alpha sine beta. So can we say that x is equal to half of 2 sine alpha sine beta, right? Why we have done that? We know that we want to apply the formula of 2 sine A sine B. 2 sine A sine B is cos A minus B minus cos A plus B. So half of cos A minus B minus cos A plus B. Now we know one thing, that alpha plus beta is 90. So cos 90 we have. So cos of alpha minus beta minus cos 90. So half of cos alpha minus beta minus 0 is equal, so x is equal to half of cos alpha minus beta minus 0 will get cancelled. Okay, so can we apply the formula of for cos A minus B? Cos A minus B. Cos A minus B. Okay. So sine alpha minus beta is half of cos alpha minus. Sine alpha sine beta is half of cos alpha minus beta. Okay, in case where alpha plus beta is 90, right? Okay. So how do we simplify this? Okay, let me see. So cos of alpha minus beta always lies between -1 and +1. Okay, so we can say that half of cos of alpha minus beta is greater than equal to -1 by 2 and smaller than equal to 1 by 2. And half of cos of alpha minus beta is nothing but x, which is sine alpha sine beta. So sine alpha sine beta lies between -1 by 2 and 1 by 2. So the minimum value of sine alpha sine beta is -1 by 2 and the maximum value is 1 by 2. Yeah, that's it. So we were getting confused kamaka. This was the final steps which was needed. Great. So that was the last question. So I will give you this next exercise. Very interesting part. Tricky questions. Some tricky questions you need a lot of practice, but interesting. Very nice. See you in the next class. Bye-bye.